Hey guys, Mr. Murray. Today I'm going to talk to you a little bit about scientific notation. First of all, what is scientific notation? Scientific notation, in a nutshell, is just a way to write, a method for writing really, really large numbers or really, really small numbers. And not the kind of large numbers or small numbers that we talk about when maybe we're talking about our bank account or the number of baseball cards we have in our collection. But we're talking about the types of numbers we're talking about when we're talking about the solar system, or going in between stars, or even going the other way and going down into cells and atoms and whatnot. So simply put, scientific notation is taking a very large number and writing it in the form of A times a power of 10. Okay, now let me give you an example of what this might look like. Let's say that we want to talk about the distance from Earth to the Sun. And Earth is relatively, a good estimate is about 93 million miles. The Earth's about 93 million miles from the Sun. That number we can make sense of, but in science, scientists might take this and we want to have a number A where A is greater than 1, or greater than or equal to 1, I should say, and less than 10. In other words, we're going to get that, we're going to take that and we're going to make it so that it's a number that we can make sense of. The way we do this is pretty simple. At the end of every number that we talk about, whole number, there's a decimal point. We don't always see it because if there's nothing after it, we tend to drop it off of there. But we're going to take that decimal point and we're going to move it so it goes right after the first digit. That's going to give us a number that's greater than or equal to 1 and smaller than 10. Okay, so here in this case, I moved the decimal point from the end of the number to put it after the 9, so I have 9 3/10, and then I'm going to multiply that by a power of 10. Well, the power of 10 is based on the number of decimal places that I moved the decimal point. So for example, here, I took my decimal point, moved it in front of the 3, so I moved it 1, 2, 3, 4, 5, 6, 7. So that would be 9 3/10 times 10 to the 7th power. This number is scientific notation for 93 million. We can do it going the other way as well. We can do it going the other way. When I say the other way, I mean we can do this where we have a negative exponent on our power of 10. So we're starting to talk about smaller things. So if I have the decimal number 0.0000084, all right, and I want to write this in scientific notation, here you can see the decimal point, all right, so I'm going to take that decimal point and I'm going to move it so it gives me a number that is greater than or equal to 1 and smaller than 10. So in this case, I'm going to have to move it right between the 8 and the 4. So that gives me 8.4, 8 4/10 times 10, and I move the decimal point 1, 2, 3, 4, 5, 6 places to the right. When I move the decimal point to the right, it's a negative exponent, so it's 10 to the negative 6th power. So that is scientific notation, taking very large numbers or very small numbers and putting them in a form that is easier to understand, easier to read. Now, the numbers I chose here weren't really that difficult to read, but where scientific notation starts coming in real handy is, and I'm just going to make something up here, if we're talking like the distance from Earth to the next solar system, we might be talking, some ultra large number, 7, 6, 5, 4, 3, 2, and I'm just going to put a bunch of zeros here, just so you get the idea that we're talking a long ways. All right, so this number, lot of us wouldn't even have a clue on how to read this number. In scientific notation, I don't have to know how to read it. I just need to know that I'm going to take my decimal point from the end of the number and I'm going to move it all the way up here so that it gives me a number that's greater than or equal to 1 and smaller than 10. So it's going to be 7.65432 times a power of 10. And again, the power of 10 is how many places did I move the decimal point? Well, I grouped them I did this intentionally. 3, 6, 9, 12, 15, 18, 21, 24, 27, 28, 29. So this would be 10 to the 29th power. This is where scientific notation helps make sense of numbers. Guys, that's it for today. If you have any questions, you know where to get a hold of me.